All right, everyone. Hopefully you had a chance to get some caffeine and sugar to power through the next session. So our next session is going to be a panel on the built environment. We're going to be joined by Norhan, Shide, and Ramon to share some of their research and some of their experience and perspectives on the built environment decarbonization problem. I have some questions to start us off, and then we'll open it up for questions from all of you. Feel free to just raise your hand and chime in, or we have a forum online, and hopefully one of my co-organizers can be monitoring that during the panel. So without further ado, does this work? Okay. Great. So we can start, I think, just with some introductions from the panelists. My name's Charles. I'm a roboticist here at MIT. I'll be moderating. And joining me are Ramon, Shide, and Norhan, and hopefully we don't have too many technical issues with the chairs. Okay. Yeah, or just grab the cables too.
Yes.
All right, so just to start, could each of you just give us a brief introduction to yourselves and your research, just giving us a sense of the problems that you study and the impact that you hope to have through your research, and also give us a little bit of a sense of the kind of technical tools that you rely on in the research that you do. So we can start with Ramon.
Sure. Hi, great to meet you. I'm Ramon, and I'm doing my PhD with Christoph, who you just heard the talk before. My background is kind of a bit mixed. I worked as an architect. I did most of my studies in architecture, and was kind of always fascinated and kind of doing research at the kind of using experimental design and kind of using technology as a tool to make kind of new types of buildings and construction methods, and investigate kind of maybe things from a robotic side through a fabrication realm. And so, but then now kind of during the last 4 years as a PhD student, I kind of went back a little bit and kind of thought more to scale up these things and think about how could we kind of use all these technologies that we use to make buildings like this, that have complex geometries, and kind of use them towards analysis of everyday building, and kind of thinking about how we can kind of deploy these methods in generative design and so on to kind of analyze and kind of make buildings use less energy in terms of carbon emissions, both in operation but also in kind of their structure, that they use less materials and things like that. Yeah.
Hi, everyone. My name is Shide, and great to see you. I am currently holding 2 positions, one in academia and one in industry. I am a research associate at Harvard Graduate School of Design. I also work as a professional engineer in industry, so trying to see both sides of this spectrum and bridge the gap between the academia and industry. My research, if I want to elaborate more on my research, I would say that my research interests are mainly twofold. On one hand, my research heavily focuses on prediction models, such as occupancy prediction model, data-driven usage patterns models, all based on machine learning algorithms or numeric methods, and then incorporating those models into building design and operation control and optimization. So I work with a lot of optimization algorithm to make building energy efficient, and at the same time make people who is using those buildings happy. So by using those prediction model, we can inform the designers or the facility manager to better or more optimize design the building and operate the building. On the other hand, I'm very interested in thermal comfort research, more specifically developing new metrics that could be used for situation other than business as usual, for example, thermal comfort during sleep, or more importantly, when we have very severe climate-related harsh events, extreme events such as heat waves or power outage. How we are going to make a built environment which is livable in those situations and basically tackle the survivability problems. I am trying to see how, I'm very interested to see how robotics, computer science, AI can help us in that regard to know or to be able to predict what would be the worst case scenario in those situations and be prepared for that. So that's another topic that I'm really interested in. And most recently, we are working on carbon neutrality for buildings, incorporating embodied carbon and operational carbon into the equation, and find out, comparing to the traditional analysis that only focuses on utility savings, if we incorporate and bring embodied carbon and operational carbon to our equation, how our decision would change, or how we can support our retrofit scenarios, how the ECMs, the energy conservation measure that we are going to use for retrofit projects or new build projects may change if we account for those parameters.
Okay, hi everyone. My name is Norhan. My background in architecture. I have a very similar journey to Shide. I'm a research scientist here in MIT Environmental Solution Initiative. I also founded a company out of the research that I was doing in building technology called Lamar.ai. My research is basically falls in the intersection of building and urban performance and how we can mitigate climate risks. My PhD was mainly looking at how we can predict heat risks using some information from building envelope, and this is what the company is doing right now. So we were using drones with thermal imaging and AI, computer vision algorithms specifically, to detect these anomalies while the drone is flying, and just give you an information of where are the thermal defects in building and how this could influence building energy efficiency and thermal comfort, and how this relates also to climate risks and specifically low-income housing. In addition to the company, I'm also doing research right now that try to expand drone application and other climate change risk mapping. So one of the projects that we're working on, we're using drone and LiDAR data and machine learning algorithm to predict landslide in a city in Colombia called Mocoa. So this is one of the research that would require a huge amount of data, and there are a lot of limitations of data collection in a setting like in the Amazon area. So this is also one of the projects that we're using drones in the different applications.
Great, thank you. And Norhan, I'd like to follow up on the data that you mentioned. So could you tell us a little bit more about what types of data you use for these projects, both on this like environmental risks, but also for these retrofitting support? And also as a follow-up to that, I'm curious, is there data you don't have that you would like that's on your wish list?
Yeah, it depends on the research question. So for the energy efficiency and the thermal comfort specifically, from the scope that we're looking at, the main data that we would require is the existing building performance, because one of the major challenges with simulation model that we do on assumptions that the building is performing according to design standards, but there is this degradation in building performance over time due to climate conditions and the operation of the building. So this is why we were relying on that first research area on using drones with thermal imaging, because thermal imaging could give you an instant information regarding how the building condition is right now. The other one, it's completely different research problem. So we were trying to understand what's beneath the tree canopy. And usually you wouldn't be able to get this information with regular photogrammetry and RGB data sensors. So we're using LiDAR, but of course comes the challenge with the data processing and how we can extract that type of information. So I think there is a challenge with data usually with every research question. It depends on how you are tackling that approach. One of the major things also that we're looking at right now is to understand how we can get more up-to-date information at the urban level. So similar at the building, how we can scale up at the neighborhood level to get the same type of information on the existing building condition much faster way.
Can I maybe like follow up on that and maybe frame things a little bit, because I feel like we're like the architects speaking to mostly like robotics, computer science audience, to kind of show like there is like a huge like problem I think that we have in like the built environment, where buildings are extremely hard to design, and they like factor in a lot of different disciplines to design them, and design decisions that are not kind of known by all the actors, right? So like you as an architect might design a building, but it might perform terribly thermally, but you will only know that at the end of the design process, because you kind of have to go to a specialized engineer to ask that question. And I think it's kind of a lot of like the research that we're also talking about is like thinking about how could we kind of better inform also the design decisions of new buildings, of like regulation around, like you mentioned, like urban environments because of like heat island effect and things like that. But just kind of, I feel like we're very, because the buildings are much kind of larger and very like super complex machines, it's kind of such a, it's still like they're not very well understood, I would say, right? So like we don't know like kind of everything that's going to happen, and there's a lot of kind of I don't know, like technical kind of work that is being done that is very hard to like control at the outset of the building. And I think a lot of like, I feel like interesting research is also kind of trying to figure out how we could like inform design decisions of architects who are mostly very like untrained on like an engineering level. They don't like anticipate a lot of like the challenges that come with like thermal or like kind of energy use, et cetera, or then also like embodied carbon. And embodied carbon, I don't know if we talked about it before, but that's right, like the material or like the carbon associated with the materials inside your building. And there's also kind of very interesting effects where maybe your structure, because it's very low embodied carbon, might be great in terms of that, but then it might result in a structure that's terrible from an operational standpoint. So there's also then like effects, kind of the different disciplines that help architects design better buildings also have competing interests. And it's kind of a very like hard thing to like negotiate and kind of think about, because it's such a like
compensation problem.
Yeah, exactly.
Yeah.
That also, as you heard with Christoph, it ties into the grid, it ties into like a national level, it ties into building regulation, it ties into politics. It's like a very, it's like a messed up problem. Yeah.
Yeah, and following on data collection, at least based on my experience, I was working with occupancy data a lot. And it may sound very easy, but actually, believe it or not, it's a very challenging process because of all the privacy issue and everything. Like the best way, the most accurate way is to put a camera, capture people, and then do the post processing. But we cannot do that because of all the privacy issues. So we have to come up with other solutions that's gonna jeopardize the accuracy, and maybe even it's gonna even more complicated the process. So I think one of the main challenges is the complexity of the data analysis that we are dealing with. And that's why specifically in industry, people are not using the results of our research because it is way complex. They require to have lots of resources to find out what's going on and basically process that data and then use it. So in industry, nobody is working out of box. They are using typical occupancy profile for all buildings, like all different kinds of buildings. And although in my PhD, I did this research, and through simulation, I found that, and so many other people confirmed that occupancy matters a lot. It was till last week that I was working on a couple of public school projects that I actually saw the impact of occupancy. Those are public schools in Washington, D.C., and they have to be net zero. So they have to have a very minimized energy consumption. And through thorough analysis, we find that this is impossible, other than incorporating very accurate occupancy profiles and behavior into our model. So it was a very time-consuming, even for me that I'm experienced in that area, it was a very time-consuming process for me to fine-tune my model to properly reflect the occupancy behavior and being able to hit the target EUI. So what I'm trying to say is that we need to find a way to simplify these things. We have lots of great means, and nobody is using it because of all the complexity, all the post-processing requirements, all the efforts that's required afterwards. In terms of data collection, we are good. I would say that most buildings, not all of them now, are equipped with some sort of data collection systems. But how we are going to properly use that, that's the main challenge.
Yeah, that seems like a persistent challenge that Christoph also brought up, is that the number of sensors and the number of actuators that we have is actually quite limited. And especially like, a sensor might cost, $50, $100, but scale that by 100 rooms in a commercial building, like it becomes a huge challenge. So could you, just as a follow-up on that, Shide, what sort of sensors are people using today to get things like occupancy data?
They are mainly use radar-based detection systems that act like a radar and detect moving people. So it's not that accurate. It's basically oversimplified the occupancy prediction or occupancy follow-up. But that's, or like through the Wi-Fi, they try to count the number of devices connected to the Wi-Fi, but I'm saying like all of them are not as accurate that other detection systems, but we have those like privacy problems and those kind of things.
Yeah, that makes a lot of sense. One topic that I'm interested in exploring more is the kind of balance between like persistent sensing modes, where you're sensing over the lifetime of a building or over on a daily basis or weekly basis, and kind of more spot check sensing modes, where more like Norhan in your research, flying a drone to assess the building envelope, potentially not every day, but like how do you balance kind of these like persistent long-lived sensors versus these more intensive, one-off evaluations?
So again, it depends. In the case of thermal imaging, you need to do this in the right time. So for example, you need to have a good temperature differences between the inside and the outside of the building to be able to see these defects and anomalies. So it's not something that you can monitor regularly, even if you have the tools. So for example, there was this technology that was developed in a research group in NYU. They did this robotic system that climbs the building and collect also any type of physical defects and any type of thermal issues that is happening on the building envelope level. But of course, you can't do this every day because it's not going to give you the right data that you're looking for. But if you're looking for a different problem related to indoor conditions, that's something that you need to monitor regularly because like Ramon and Shide said, like the building is very dynamic and you can't control how the people are using the building or how many people are in the building within a specific time. So you need to be able to develop some sort of a holistic approach to be able to understand how these variables are affecting the performance of the building and the thermal conditions as well.
I think they're also used for different things, right? So like mostly I would say like for these post-occupancy assessments, and they're also kind of very important tools to like fine-tune if the mechanical systems are actually working. Like there's some really interesting like case studies of like the biggest like net zero buildings, and they needed like 2 to 3 years to like fine-tune the building to actually be net zero, right? Because you install a building, it's a huge mess, it's a construction site, maybe not all the sensors are working, like some AC might just be on the whole time, you don't know what's going on, like the systems are super complex, and so it's kind of also like a thing to like kind of tune the building to then actually work as you intended, or maybe you figure out that users leave certain doors open that will in turn then kind of, have some cascading effects on like airflow and so on that you don't anticipate, right? And so kind of thinking about that. And then I think your example with the thermal imaging is extremely important as like a one-time also like retrofit, right? You like go through like a building like here and you see like what's wrong. And you can do that kind of not every day, obviously, but it's more like every decade, right? Kind of.
Yeah, that makes sense. And then as a follow-up question to that, there seems to be this question of like, there's this operational data from the building, in internals and the envelope data. What is the best way to take like the learnings or the like insights from that data and bring it back into the design stage of these buildings? So like what can architects and building engineers learn from this operational data to kind of inform their design of net zero buildings?
Well, maybe one thing that you could learn is kind of, I think as we mentioned, is like building occupancy is extremely important to kind of figure out even when people are using a building, right? So if you do a building energy model, one of the most important aspects is to predict how many people are in the building, how many people are kind of using like a building's like appliances, etc., and to just kind of have better models of like who are your future occupants going to be will increase the kind of accuracy of your energy models and can then help you fine tune things like airflow for natural ventilation. It can help you kind of, maybe even figure out different HVAC systems that you need, et cetera, to kind of like increase that accuracy.
I can add something to that. I think the more important than occupancy presence, it's the personal thermal actions that people take. Opening, closing the windows, turning on or down the temperature. Those type of behaviors can help us a lot to inform the design. So usually how people are using their environment in terms of the thermal condition, because that's the main driver of energy consumption. So I think that's gonna be very helpful to learn from and then inform the design for the next buildings. I have a question about that, but after you, Nora.
No, I was just gonna add one of the things that also could be useful is like the type of system that have the highest rates of failure, because that's something that we keep noticing, that there are specific insulation system and a facade system that have the highest likability of failure over a specific time period. So that's something that could also inform the design of new buildings, for example. And we even noticed that in new buildings that there are some systems that have some issues already and the building just opened. So that's something that also could be useful for designers and architects.
So my question is, I wanna ask you guys, what do you think? When we are working with data, as Norhan mentioned, it's very problem specific. So basically, it's not a one solution fits all. We have to monitor a building and then make our decisions based on that. But that's going to be very costly, as you mentioned. How we can generalize this process? Is there any way that we can monitor a good number of buildings and then make some generalized recommendations? For example, for a school types building, or for commercial buildings, for residential buildings. Is it possible, or what is required to reach to that point, not being required to monitor each and every building, keep repeating the same process over and over?
That's a really great question. And if anyone in the audience wants to take a stab at answering that, feel free, but also start thinking of your own questions, because we'll open it up for audience questions. But I think that's a really interesting question. I wonder, there's a lot of model learning work that we do in robotics where we can try to come up with ways of learning the dynamics of different systems, but it seems like it's important to fine tune to the specifics of the geography or the buildings or the occupant patterns that you
Could
see.
we have something similar to ChatGPT that could be used for the built environment? Is it possible?
Yeah, I'm curious.
In some way?
Yeah, what would a foundation model for, say, a building occupancy look like, or these generalizable models that can move from domain to domain?
I just had a question that maybe addresses that question. Is when we're talking about data access to sort of these observations and sensing, how open source within the architecture community is this data? Are there centralized repositories for these? Because I feel like that could be a step towards generalizing some of these relationships and dynamics.
It's extremely inaccessible.
Yeah.
I'm just going to repeat the question real fast so it's on the recording, but the question was on open source data accessibility for these problems.
It's extremely inaccessible, and I think that's one of the biggest problems.
Exactly.
I think architecture as an industry is a very analog industry that hasn't changed much, and kind of I think I was working at an architecture firm in 2014. We submitted one of the I think maybe one of the world's largest single mast bridges to construction stage, the Danjiang Bridge in Taiwan, and that was the first time that ever an architecture firm gave a 3D model to a contractor. In 2014. That's insane, right? And so before that, you would and still now for most projects, people will print out literal drawings. The contractor will take the drawings, will measure stuff on a physical drawing to even do material estimates and things like that. And that's how 5% of the industry works, right? And it's and so there's no data. So basically you're if you're a big architecture firm, Gensler or Zaha Hadid Architects, who I work for, it's yes, you have a lot of data, but that's your data, right? You're not going to give that away. But if you're like the public, you don't have access to that data. And so, but now I think there's a lot of interesting progress with, especially around like embodied carbon legislation. So there's a lot of place, I think in the UK now, you have to report the building materials that you use to build your building. And so I think now in the next few years, we're going to see that people actually like will have to open source their like full geometries of buildings to kind of the public to do this kind of reporting, which is like a great first step to kind of see. But it's 2024, right, when these like legislations are in place.
I just want to add something to your question related to the privacy issue that Shide mentioned earlier, that a lot of building owners, architecture firms, they take their data very sensitively. So, because especially with existing buildings, because you're dealing with actual data of real occupants. So there is this major privacy issue that you need to adhere to. But however, on the other positive side, there has been a lot of new research that try to deploy like computer vision techniques to make use of open source data, like satellite data, Google Street View data, to infer some information that could give some indication of building performance. Of course, it's not perfect, but there is some progress toward that space.
Any other questions from the audience?
I'm stuck on that data question. Like, there must be some economic incentive, right, for not sharing your data. That's why they're doing it. Like, what really is that economic incentive?
I mean, I think there's two. Like, there's one is like the privacy question with like the occupancy data, right? Like, you can't just like, I don't know. I mean, you can't ask people to like just give up locations of people in buildings.
Yeah, because they have spent money to collect that data.
Yeah.
They have built the infrastructure for collecting that data, and they are not willing to give it for free. We should think of some sort of reward for them that is good enough for them to be willing to basically share that data, and we don't have it right now.
I also think there is a very different angle to that when it comes to the business side. So especially when you work with new building or existing buildings, the operators of the building, they take the data, especially in the domain where I work, like the building conditions, very sensitively, because they want to come to the public and say, this building just opened 2 years ago and there is a lot of issues already. So that's also another issue why they don't want to share the data. They just keep that data private and they don't share it.
Okay. Interesting. Thank you.
I want to circle back to the like spot checking with like robots idea. So let's just assume you have some system of multiple robots where you can have them like walk around or like drive around indoor, and then right now they can collect for example like 3D geometry data, this kind of stuff. What kind of additional data you guys would like to see with this sort of robotic system?
I would say for building systems, having an automated fault detection matters a lot, because these days everything is doing, as far as I know, manually. People go to the site, check the systems. If there is faulty or malfunctioning components, they take the necessary action, replace the component. But what if they overlook some hard issues that would later on lead to a very severe damage to the system that could cause a hard problem, hard fault, and we need to shut down the system that would eventually cause the building consume more energy. So if we can have an automated way for these fault detection and diagnosis, that would be perfect. It could be continuous. The robots can go through the systems, through the pipes. If there is any dirty filter, some valve malfunctioning, or like pumps are not working properly, if they can detect them as soon as possible, it's much easier to fix them. So basically, we are saving the energy, we are saving the cost, time, effort, everything. So I think that could be something very interesting.
I think another point to add to this is the urban level data acquisition, because especially at the urban scale, data is very, very limited, especially when it comes to outdoor thermal comfort, emission level, air quality. So that's also another point. The other aspect of data that are inaccessible right now, which is in a very specific conditions like post-disasters. And this is one of the growing domains right now, is how you can deploy robotics to inspect damage in buildings and identify the structure damages, even in post-war areas. So that's kind of like these new things where robotics can have the huge effect.
Yeah, there is a quote says, like following up on the extreme events or disasters. There's a quote says, water is the prime medium for you to feel the climate change. And if you think to yourselves, you can feel that we have more rainy days these years compared to the past. And also the data analysis showed that we have much more precipitation these days. And we have these flood problems, and we need to come up with flood resilient buildings. So using AI, robotics, I don't know like how it could be. It's not my area of expertise, but finding out how that could help us to build a livable environment after these extreme climate hazards like hurricanes or floods, how to, as you, Norhan, just mentioned, how to map the construction defects and bring that information to the AI intelligence in order to support the retrofit scenarios.
Yeah, and I think this question of like the persistent sensing at the urban level is really interesting,
Yes.
especially for, I can imagine all sorts of like, not just extreme weather events, but these like kind of creeping changes of climate change, like ground subsidence, and like there's dry weather flooding in Miami now, and all of these things where you could try to quantify some of that risk. And I don't know how you would use that as an architect, but I guess my field would be gathering the data.
It's going to definitely inform the architectural design for future.
I mean, also with the whole like infrastructure, kind of
Yes.
thinking of the city not as just like individual buildings, but as kind of a system of like interconnected like pipes, sewers, you know, like, and kind of in public infrastructure, public transport, that all kind of are interconnected, right?
Well, this has been a really great discussion. I'm keeping an eye on the time, but we have time for one more question.
It's a quick question, just some concern. So it seems that we are thinking about robots mostly as sensors, right? To get situational awareness of what's going on. We measure quantities with robots potentially. But let's say in 10 years, like 20 years, we'll have a lot of humanoids capable of manipulating things around and capable of acting in the environment. Is there any role for this, like, in the built environment, if we can have the robots, like, manipulating things? What is the most useful thing that they can do for you guys?
I think in like terms of also maybe what you're hinting at, like construction robotics, I feel like there is at the moment kind of the field, I think for the last like 20 or so years has like tried to like emulate a lot of like human ways of building with robots, right? There's a lot of like examples of using like the robots we use in the car industry for like architectural applications, like for like, but then kind of imitating like things like bricklaying and so on, where it's kind of, I don't know, to me it seems like there would be better ways of how you could like fine tune maybe and develop like new types of robots together with like construction systems, because something like kind of the brick wall, right, is kind of, a brick is the size because it's kind of made for you as a human builder. You can like carry a bunch of them on your construction site, you can place them all day long without getting tired, and it's kind of like, it's like over like millennia this like brick has been like fine-tuned to us humans, right? And so to kind of then think about like robots like one-to-one replacing that, I think there will be much more like opportunities if you kind of started to like rethink maybe construction systems that were robotically buildable, right? And kind of think about those kind of how they would go together. I mean, I think maybe one of the like prime examples is like the most, I would say, mechanized kind of parts of the construction industry are like some timber industries, especially in Europe or Canada, where kind of you have like large scale CNC machines that like kind of build up whole like wall sections more or less automatically with like kind of, but they're not like maybe your like car robots, but kind of different like ways of like automating systems to kind of build them. And I think kind of maybe thinking a bit outside of the box and not thinking of like just like replacing a human with a robot, but kind of how you could like envision tasks that are like kind of better suited for like robot like fabrication collaboration.
I just want to add something to your question related to 20 years. You're saying this will happen in 20 years. Believe it or not, people are asking this question right now. When we do like the analysis of the building envelope, they say like, is there a robot system that could go inside the wall and do the repairs instantly? So I think this will even happen faster than this time horizon, because there's also a growing need that people want to make everything happen faster and automate most of the time-intensive tasks that in the construction industry specifically right now.
It's quite exciting.
Yes.
One more quick question, please.
All right. So besides buildings and architectures, do you have some visions, or do you think there are some possible application of robotics in like at the city scale, at some like green spaces and some parks? Like, do you have some idea on these sort of applications? And
I know that there are already some sort of smart balls. I think there are some sort of robots that go through a sewage pipeline, and they are sonar-based detection system that emit waves. Those waves gonna hit the wall of the pipe, and then they can detect any sort of leakage, water hammering, or cracks, or those type of things. So they are basically doing this in a scale of infrastructure. And when I read about that, I was thinking it would be like amazing if we could have something similar for our buildings to go through all the pipes and detect all the problems. But I don't think that we have it right now. But that's one example I'm aware of.
I think also in infrastructure at the city level, like road infrastructure, there are some new technologies right now to inspect like bridges and like even road markings. That's also a growing thing that's where robotic system could have a huge effect right now.
Yeah, now that you said that, I remembered my colleague was actually working on that. She was using LiDAR to map the 3D models of the bridges and find out any cracks, defects or anything, and doing some sort of optimization for the LiDAR path. Because it's in a very crowded area, usually people are like moving, cars are moving. So optimizing the path of that LiDAR to collect enough amount of data in a reasonable amount of time. That was, I think, her research question, and she was working on that. I think that's very interesting and promising. It's going to happen in a very near future.
Okay, thank you. Yeah, just sharing some experiences. So yeah, I think like under the climate change scenarios, there are like more extreme rainstorm events that happening every year. Like there are some urban floodings happening during summer. Yeah, very frequently. For example, in New York City. So yeah, I'm thinking about maybe we can develop some sensor systems and green spaces, trying to estimate the stormwater retention capacity of these spaces and trying to mitigate this potential flooding hazards. Yeah. Okay, thank you.
There's actually a company doing this. They are putting sensor in drainage system to predict if there would be potential risk with flooding. So that's already something that's been in development, but not at the sophistication level to scale up to multiple cities. It's just a very new prototype. Yeah, it's not working anymore. It's okay.
Okay. But I think that's also all the time we have for the panel, but this has been a really great discussion. So please join me in thanking our panelists. And